Hey, hello and welcome to today's GFG problem. The day uploading well. So let's say today's problem fixing two nodes of a BST. Okay. So what the problem is saying is we'll be given a BST. Okay. But there will be two nodes. Okay. Who will be wrongly placed or who will be misplaced. Okay. And because of that, like this BST is not a this binary tree is not a BST, and hence we want to correct those two nodes in order to make that tree a BST. Okay. So let's quickly see which are those two nodes. So the two nodes are this one particular node is this one, and then another one is this one. Why? Because if you see the you know what is the property of BST, right? So the right child is generally greater than, right? It's greater than the parent node, right? The parent node. And the same here as well, right? Here as well. For example, right? If we have this node and we have this left subtree, we have this right subtree, right? We have this right subtree, and right? The values or the nodes on the right subtree have greater value than the value than this particular node, and the nodes on the left side, right? They have less value than this particular given node. Okay. So this is a property of BST, but these two nodes are violating that property, right? Are violating the property of BST. Okay, and hence we want to correct that. That is the ask. Okay. Now, how can we solve the problem? Now let's come to the intuition. How we'll solve this problem? So what we're going to do is we're going to take three pointers first. One will be previous, which will be null. The first node, which is the faulty node, basically, again we'll set it as null. And the second, which the faulty node, we'll set it as null. Okay, we'll start with this particular root, right? Root. Okay. Now what are we going to do? We are going to do the in order traversal. Okay, and in this we are going to check whether the successor, right? Now the successor in the in order traversal, the successor should be greater than the previous node. Should be greater than the previous node. For example, should be greater than the previous node. We'll see. You'll understand. Okay. So we'll go to the left child of 10. Okay. Again, you know what in order traversal we process the left child first, then the root, and then the right child. Okay. So again we'll go to the left, extreme left. Okay, 2. So now we are going to go to left again of 2, but there's no child of 2, so we're going to come back. Okay, after coming back, we are going to check if previous is not null. All right, previous is not null, and root dot data, if it is less than previous dot data, that means it is violating the property of BST. Okay, property of BST, because root dot data is the current node and previous dot data is the previous node. Okay, so root dot data generally needs to be greater than previous dot data. But if it matches this condition, then we have found a faulty node. Okay, we have found a faulty node. Okay, currently previous is null. Currently previous is null, and hence we are going to go. We are this condition won't match, and we're going to go ahead. So here we are going to write previous equal to root. Okay, that means what is the root now? Root is 2. For this, right, this particular, we are at this particular node, root is 2, so we are going to assign 2 to this. Okay, then we are going to go to the right subtree of right child of 2. Okay, we are going to go back because there's no child, no right child. So we are done processing 2. Now we are going to go back. Okay, once okay, now again, once we go back, we have done process the left child of 5. Now we are going to come to this condition. Is previous not null? Yes, it is not null. Previous is holding 2. And is root dot data less than previous dot data? No, root dot data is not less than previous dot data. Root is 5. That is not less than previous dot data. Okay, so so we are good here till now. It is following the property of BST. We'll just execute this statement, previous equal to root, which we will now update to 5. Okay, now we'll go to the right subtree. Okay, the right child. Okay, here 20. We're going to go to the left. We're going to come back this since there's no child. After doing that, we are going to check previous is not null. Yes. What is root? Root is 20. Is 20? Root is 20, right? Yeah. So root is 20. So um, so yes, so root dot data is not less than previous dot data. Previous dot data. Okay, the which we are good here, right? We are good here because yes, now till now still it's good, right? Still it's good. 20 is not less than 5. Okay, so we are just going to update this, execute this statement, previous equal to root. So we're going to update to 20. Okay, we will update to 20. Now we are done processing the left children or left subtree of 10. Okay, now we're going to go back from here. Okay, we're going to go back from here. Now we're done processing the left subtree of 10. Now again we'll come to this condition. Is previous not null? Yes, not null. Root dot data, which is 10. Is it less than previous dot data, which is 20? Yes. So 10 is the successor of 20 in order traversal. 10 is the successor of 20 in order traversal. And if you see, what does the property of BST says? All the left child should have lesser values than the root, than the node. But it is violating the property. Okay. So root dot data, which is 10, is less than previous dot data. Yes. So we have found our first faulty node. Okay. Which is, we are going to check. If first equal to null, right? If first equal to null, in that case, assign previous to null. Assign previous to first. Okay. What is previous? Previous is 20. Okay, so we are going to assign 20 to first. Okay. Okay. So we are okay. Now second equal to, for now we'll assign root. Okay, for now we are going to assign root. Okay. So second is root. So root is what? Root is 10. So for now, second is 2. Let's say. Okay, let's say. Second is 2. Okay, now we'll come to this particular previous equal to root. So we're going to update previous as well, which will now become 10. Now we're done process. We're going to go to the right subtree of 10. Okay, now we'll go to try to go to left, but there's no child. We'll come back. Now after coming back, this code will be executed. Previous is not null, and root dot data, which is 8, okay, is less than previous dot data. Right, again it is violating the property because this node should have had greater value than this root, this particular node, right? This particular node. Okay. So here, first we already have first, so second will be updated. Second equal to root. What is root? Root is nothing but 8. So this is the other faulty node, 8. Okay. So now we will assign this statement. Previous will be 8 now, but we are done processing all the nodes of the BST, and we have our two faulty nodes. We've got our two faulty nodes. Now simply what we're going to do, we are just going to swap their values. We're just going to swap the values. So how it will look like? So 10, 5. What is the left subtree? 5. Then right subtree is 8. Right child is 8. Then 2 and 20. So this was a tree, right? Now we're going to, since these are the two faulty nodes, we are going to just swap. So it will be 8 and this will be 20. So this will be our BST. Okay, this will be our BST. Okay, our corrected BST. Okay, I hope you have got this intuition. Now just one request to please subscribe to the channel, like the video before we go to the code. Okay, so first I'll show the Java code followed by C++. Let me just trying to reset this. Now let's implement. So as I said, we are going to take three pointers. One will be previous equal to null, then first equal to null, then node second equal to null, right? So we have our three okay, we have a three pointers now. Now what we're going to do, we are going to implement this function in order traversal root. Okay. Okay, then we have our okay, we have implemented this. What will be the base condition? The base condition will be simple. If root equal to null, then return from here in order traversal, pretty big function name, root dot left. We are going to go to the left child, process the left child. Once the left child is processed, we are going to write a code. I have already shown this this business logic. If previous is not null and root dot data, if it is less than previous dot data, that means we have found a faulty node. We're going to check here. If we have not found the first faulty node, then we are going to assign this previous to the faulty node. Then second equal to root, we are going to say. Okay. And here, what we are going to do? Okay. So here, previous equal to root. Okay. So this is it. This is it. This will solve a problem. Now, one more thing we want to do here is, if first is not equal to null and second is not equal to null, that means there are faulty nodes. There are faulty nodes. So what we're going to do, we are just going to swap first dot data, only data we are going to swap. First dot data equal to second dot data, second dot data equal to 10, right? That's it. Let's compile this. Oh, what is the issue here? Let me check. We missed processing the right subtree, right? That is one of the important things. Okay. So right. Now let me compile this again. Okay, let's submit it. Now we'll see the C++ code as well. Okay. So thanks for watching. Please don't forget to subscribe to the channel, like the video. I've tried to make it very easy for you. Let's quickly see the C++ code as well. So here's the C++ code again, 3 pointers we have taken. Okay. And then we are calling the in-order traverse, this function. Okay. And then if it is null, right? Then this is a base condition. Okay, we are calling the left child, and then here it is a business logic. If previous is not null and if root dot data is less than previous data, then yes, it is violating the property of BST. If first faulty node is not found, assign previous to first node and then assign root to the second. Okay, so and finally, like even if the previous is null, right, or if this condition is not matching, then still assign the root to the previous. Okay, and then go to the right subtree. Okay, thanks for watching. I'll attach the code in the description section. Please subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.